So with this video, you will understand the true energetic cost of making ATP. And the synthesis of ATP uses reactants ADP and inorganic phosphate. And we fabricate ATP, and this involves generation of water, so we can include that as part of the reaction. And the advertised cost of this reaction is delta G under standard conditions of 30.5 kilojoules per mole. And what standard conditions means is that we have 1 molar ADP, 1 molar ATP, and also 1 molar phosphate. And those are completely unrealistic conditions for the cell. First of all, the cell wants to have a much higher concentration of ATP compared with ADP. So the ratio of ATP to ADP in a healthy living cell is going to involve a very high ATP to ADP ratio on the order of 100 to 1. And the other difference from standard conditions is that the phosphate concentration is approximately 1.5 millimolar, not 1 molar, 1.5 millimolar. And these this situation means that it's more difficult to make ATP than if we were at standard conditions, because we have less than 1 molar inorganic phosphate, and we also want this whole balance to favor ATP so that there's a high ATP to ADP ratio. The true cost is in a healthy living cell is this value, 58.4 kilojoules per mole, meaning we need to work harder to make the ATP if we are thinking about the work done by ATP synthase. Where did this number come from? Well, you have to first understand that the energy under the cellular conditions is the sum of the standard free energy change, which is this value of 30.5 kilojoules per mole, plus the RT times the ln of the products of our reaction. So CD, this is the general form, divided by the activities of the product activities for our reactants. And so now we're going to replace C and D with our products ATP and water. We can ignore water because the activity of water is always taken to be 1. So we would write plus RT ln concentration of ATP divided by concentration of ADP and inorganic phosphate. So here we see that we need to take the ln of this ATP to ADP ratio. This ratio is approximately 100. So we can substitute in here RT ln of 100 divided by the concentration of inorganic phosphate, which is about 10 to the 2 times 10 to the minus 3 molar, or 2 millimolar. 2 millimolar. R is 8.31 times 10 to the minus 3 kilojoules per mole. And temperature, a good value here, is 310 Kelvin for something at body temperature. And we do this math, and we get a value of approximately 27.9 kilojoules per mole. So that's the extra cost that it takes to make ATP at this high ATP to ADP ratio and under physiological phosphate concentrations.